Jack. Can somebody from the Jack group give me 5 numbers?
Minimum is 30. Q1 is 33. The median is 49.5.
That's going to be over close to 50.
Q3 is 71. And the max is 77.
That's going to be over here. All right. So this was, say them slowly again.
The minimum is 30. The Q1 is 33. Median is 49.5. Q3 is 71. Max is 77.
Okay. So now we go ahead and make our box around the middle 3. And as a lot of you said for Jack, one reason you liked him is things were really close together. So 50% of the data values are between here and here, and very small percents going out, or 25% on each side, but they're not that far out. Okay, Timar, the 5-number summary. Someone can give us, yes.
The min is 5. Q1 is 12.
Q1 is 12. That's going to be over here just a little past 10.
Median is 50.
Everybody's lining up pretty close to the middle.
Q3 is 88. And then the max is 95.
95. So 80, or was it 88?
88.
88. So that's wrong. 88 is right here. So this is what we knew about Timar just from looking at it, that his numbers, while he has some really high scores, are a lot more spread out.
Yeah, but he's increasing his
Could be. Interpret the test scores for each student. Jack, Aaliyah, Timar. I want you right now at your tables, interpret the scores. Do you want to divide and conquer? Or do all 3? Divide and conquer. You guys have Jack. What does that box and whisker tell you? You guys have Aaliyah. Middle 2 tables have Aaliyah. What does this box and whisker tell you? You 2 tables have Timar. What does his box and whisker tell you? I'm walking around.
Didn't we already say what his
You said it out loud, but now we gotta write something down.
What is interpret?
Decide what it means.
Wait, and then I have
Okay, but talk to him now. You guys are on Aaliyah. What does this shape of this box and whisker tell you?
shape.
Riley has high scores. His numbers are more spread out.
Yeah, I might be saying it wrong, huh?
Hey, Mr. Goody, look, it's a little different right there than over there.
Is that what? Oh, did I spell it wrong? Ah. There does seem to be a spelling issue.
Oh, dang.
Okay, this, yeah, good. Are you going to give a little more detail to that? Nice haircut. Good haircuts this weekend, huh?
Your mom.
Okay. Right now, at your tables, if you haven't already done so, look at what you have. Pick whose is the best at at your table, whose is the best? You may or may not have the same thing. Whose is the best?
Who's the best of what?
What you wrote down, your explanation.
Alright. Do we get to write it up on the board?
I'm gonna ask one from each group to come on up right now. Okay, send forward one person from each table. Whose is the best? One, bring your paper, please. Bring your paper. We need one from this group.
What?
Okay, so what do we have? You are. That's all right. It's good to see things different ways. Quiet, please. Brody, tell us what you got.
They look symmetric.
What does that mean? That's good. I like that. Explain what symmetric means.
Like it's even on both sides.
Thank you. So symmetric is a good vocab word if you're asked to explain something. Distribution, is it skewed or even? So one thing to know is Aaliyah is symmetric. Thank you, Mr. Brody.
Yeah, bro.
Push yours. Yeah, there we go.
Do I read it?
Yeah, that'd be great.
The scores are really spread out in range and has some highs, and he has some really high scores and some really low scores.
Thank you. Leave that there for a minute. Brody, you need to sit down and be writing down the other. All right, thank you, Kenya. It's more consistent. It's more consistent. Wait, leave it there. It's more consistent. What does consistent mean?
More.
I see you doing this. What you really mean is
It's like in a zone.
in a zone, in a smaller zone, okay? All right, thank you. Perfect. Okay,
You know how you got that?
now, question 5. Do you think, Brody, could you read 5 for us?
Do you think these three students performed about the same on all of the tests?
Did they perform about the same? What do they think?
Yes.
I've got one vote for yes. Why would you say yes?
Because when you looked at the mean and the medians, they were all either the same or like really, really close. Because Jack had the one difference, 0.5.
Okay.
That's not much.
Who thinks these students are different? Who thinks I could draw names if I'm the teacher who's going to send one person to the spelling bee? Are they the same, or does somebody still want to make a case for them being different?
Tell me what you told me yesterday.
Okay, so we're going to agree with Isabella and say, so far what we can see is he could send either one.
Yeah, like that's their average.
Okay, if you're looking at the average. Flip the page. So who did better? You have heard. Let's see. Christopher B., could you read, please?
You have learned about the spread of data.
based on the median. However, is there a way to measure the spread of data from one measure of central tendency? Standard
Deviation.
deviation is a measure of how spread out the data is from mean.
Wait, stop there for a minute. When we've been looking at box and whisker, we were looking at them spread out from the middle. What was that middle? Was it the mean? What's in the middle of the box? Median. So box and whisker, we're looking at things compared to a median. Even that IQR with the lower fence and the upper fence, we're kind of looking at median. This standard deviation, instead of having how far away things are from the median, we're going to start looking at how spread out things are from the mean. Okay, a formula can be used to determine. Oscar, could you start reading right there? A formula can be used.
A formula can be used to determine the standard deviation of a data set. A lower standard deviation represents data that are more tightly clustered, and a higher standard deviation represents data that are more spread out from the mean.
Okay, so lower standard deviation means tightly together. Higher standard deviation means spread out. So far of our peoples we've been looking at, Jack, Aaliyah, Tamar, who's going to have the low standard deviation?
Jack.
Who's going to have the lowest standard deviation? Who is the most tightly clustered? The majority are pretty close together. Okay, so it's either going to be Jack or Aaliyah. We're going to find out. This one does have outliers further out. Okay, but the 50% are really close together. Who's going to have the highest standard deviation? Tamar. Okay, that guy is definitely the most spread out. Whether we're using mean or median, he's spread out.
But it's the best.
What? Okay. Okay. So, how we're going to do that? They give you a nice fancy little formula here. Oh, doesn't that look fun? One thing to notice is a symbol right here. Okay, standard deviation is that sideways P thing. Why is this not? Oh, okay, because I'm doing it different today, so it does different things. Okay, now, here's what you're going to do. Let's look at each part of the standard deviation formula separately. Follow the steps that determine the standard deviation. Let's use data set 6, 4, 10, 8, where x with a line over it is 7. That's the mean. First, think of each data value as its own term labeled x1, x2, x3. So here's our 4 data values. The first part of the formula identifies the term to be added. Blah, 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 blah. Don't want to do that. Next, evaluate the expression to be added. Then take each term and subtract it and square the difference. So look at what we have. First term is 6. They're subtracting the standard deviation. Second term is 4. What are they subtracting? Or they're subtracting the mean. Okay. Next term is 10. What are they subtracting? Hello. Hello. 7. Okay, so what they did is they found a mean of 7 for these 4 numbers, 6, 4, 10, and 8. Now they're taking that number, subtract the mean. Take that number, subtract the mean. Take this number, subtract the mean. Take this number and subtract the mean. What are they doing with it after they subtract the mean, though? What's this?
Adding.
Exponent.
That's an exponent. What is the exponent?
It times itself.
It times itself. They're squaring it after they do this subtract. Now they're going to take all of these numbers and find an average. You add them up, divide by how many, That's an average. So here, this is how far away from mean, 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 how far away from mean. Square, 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 average. And finally, the last piece right here. What did they do to the 5? Square root of it. Okay, so let's it'll make more sense as we do it. Okay, so we're going to take a look at Jack's values. Let's use the standard deviation formula to determine the standard deviation of Jack's spelling bee scores. Right now we're looking for a way to tell those guys apart. Identify the values you will use to determine the standard deviation. What do we need? What was one of the things you saw a lot in the math I just showed you? Mean.
Median.
Do we need the median? Not in this one. Mean. What was the mean for Jack? It has an X with a line over it. We already said it,
49.5,
and we're working with Jack.
I think.
Was it 49.5? Was it 50?
It's 49.5.
Okay. Back it on
It
up.
was 50. It was 50.
Okay. Mean was 50. That says determine the, oh, so we already have the mean. Okay. Now, here's what you're going to do. Each data value in Jack's column, we're going to take that, subtract the mean, and then square it. So the next one right here is going to be 32 minus 50 squared. Calculator out, on. Get it to just regular calculate. 32 minus 50 equals negative 18. Square it. 324. Next one, I'm going to take the next value, 33 minus 50. I'm always minusing the mean. After I get that, I square it. So in my calculator, 33 minus 50 equals negative 17 this time. Brody, are you writing this down?
Yep.
Now I push x squared equals, and this time I have 289. Each step of the way, I'm figuring out how far is this away from the mean and squaring it. Memo, what am I going to write next?
35
35
through 50.
minus 50.
Oh, minus 50 equals.
Wait, close the parentheses.
Close parentheses, squared.
Equals. Okay, so now we got to do that. 35 minus 50. Figure out what that is. Square it. 225. Okay, I'm going to walk around as you finish the rest of this table. What are we doing here? Well, there were a lot of steps, but if you take each step alone, it's simple. So what's going to be the next one? Start your parenthesis. And your fingers covering what you need. Each time you take the number that it shows for that x, that's one data value. You always minus 50, and then you square it. Good. Looks like you got how to set it up. Good. Get the pattern. Good. Yeah, and you're gonna own stuff. It looks like you haven't started to try and write them yet, so I'm just reminding you. Okay? Yes. So you're squaring them. Alright. Perfect. Most people are close. Okay. On what do we get when we work with the 49? What's the end value there? 1. How about the 50?
0.
Thank you. How about the 50 again? 0. How about the 71?
441. 529. 729.
All right. Now, quiet please. The next thing that we're going to do is find the average of all these numbers, and they have symbols they're using. This big thing that looks like an E kinda, it was called sigma, and it means sum. It means sum them all up. Sum of what you get when you take a number minus the mean from it, and then divide by however many numbers you had. So this is a fancy symbol for take an average. We need to add these numbers up and divide by how many, including this one at the top that they did for us. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Everybody right now with your calculator, we need to add those up and divide by 10. This is fancy symbols for take an average. Memo, you're adding and dividing by 10. I get 293.8. Am I in the same ballpark? This plus 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 this. Divide by 10. Wait a minute. Andy, why did we divide by 10?
That's
How many there is. So we're just taking what we got, find the average. The last step, see the fancy symbol? What are they doing here in the last step? Whatever this number is, we need to take a square root. Let's make a note to ourselves. This is an average. They're using some weird symbols, but we know how to do an average. Here's how to do an easy square root when you have a number in there. See where the x squared button is?
Yep.
You can see a blue square root, so you go second square root. You got to go second to get to the blue feature. And then if you want the answer that you just had, you could type it in, or you could go second, and down here above the negative is A and S. That means answer. And it'll pop in the last answer that you just got. So second square root, second answer equals 17.14. Determine the standard deviation for Jack's B-scores and interpret the meaning. Now, what is that 17.4? Again, what were we finding in that standard deviation? Let's go back to its definition that they gave us. Standard deviation is what we just found. What is it? Oh, man.
Is a measure of how spread out the data is from the mean.
Okay, a measure of how spread out data is from a mean. So, there we go. Get back. Okay, so, did it tell us a percent? Most data is 17.14 above or below the mean of 50. So this is how far away data points are from 50. Most data is 17.14 above or below the mean of 50. Let's go back and look at our box and whisker. This was Jack. Here's 50. You can't see it. Here's 50. 17.5. Here's 10. Yeah, so 17.5 is right about here. And 17.5 lower this way, here's 10. Okay, so it's kind of lining up with where our box edges are, all right? It's giving us the majority of the data points you can find within a certain range, but while box and whiskers focused on that median, this one's looking at the mean, and it's a certain range above and a certain range below the mean. All right?
What did you get
It's
for
gonna be in our homework packet.
B&A?
There's going to be a little bit in the homework packet. The majority of the homework packet is review of last week's stuff. But at the end, there's a couple. There will be some of this on our test. What we're going to do tomorrow is
Review?
practice this a little and learn how to do this on a calculator. Okay? Calculate. That was a lot of steps, yes? The calculator is programmed to be able to do this for us. Now, what we need to do right now, 3 things. 1, we're going to put the books away. 2, hold on. We're going to turn in last week's homework packet. 3, you're going to get the new homework packet and get started on it. Okay, so books, old homework packet turned in. New homework packet coming. I actually have some work to pass back. It would be great if I could get somebody to pass some work back. Yeah.
Did you get B&A number 2?
In just a minute, Rose. Bye.